Welcome to today's talk. In this video, we are going to talk about some interesting topics. But before that, I would like to introduce myself. Hello, my name is Abhishek, and I'm a software engineer. I have a few years of experience in Python, but now I have transitioned to Rust programming for its benefits and emphasis on performance and safety. And currently working in areas like embedded systems and security engineering. So today we are going to talk about async await, then Tokio library and axum web framework. Async await, this is a feature in Rust standard library that allows asynchronous programming. It is based on a concept of futures. Then Tokio, it is a popular Rust library for building asynchronous IO-bound high-performance network application. It is built on top of Rust standard libraries async await syntax and provides a number of abstraction and utilities for working with asynchronous code. Then we are going to see the practical use of async await and Tokio library with the help of Axum web framework to build simple web server. Axum uses asynchronous programming to handle multiple requests concurrently without blocking the execution of other requests, which allows a better performance and scalability. So let's get started. Let's start with async await. Async keyword is used to mark a function or a code block as asynchronous, and the await keyword is used to mark the pause points inside a synchronous function. Await is used where the execution of a current asynchronous task is paused or blocked until the future it's waiting on is complete. A future it represents the value that might not be available yet, or it can be thought of as a placeholder for a value which will be available at some point in the future. For example, uh, this could be a result of SQL query from a database or a file received or downloaded from a network. So instead of waiting for the actual file or value, uh, future makes it possible to continue the rest of the execution until the value is available. And one of the main benefit of using async and await is that it allows you to write a code in a synchronized fashion, uh, and but runs concurrently without the need of for explicit threading or a callback based function. This make your code more readable, maintainable, and efficient. Let's understand this more with some examples. So let's take this example here. So we have a task one and task two. The task one reads some data file, some data from the database, and let's assume that it requires 10 milliseconds. And then we have a task two, which is downloading some file from the network, and it requires 100 milliseconds. Then also have a main task, which will call this task one and task two, and to execute our main task, we are using this block on executor. So block on executor uh, is a function which allows to run a asynchronous task, and it waits until it completes. But it blocks the current thread until the task is completed, and then it returns the result. So therefore, it should be used only with a main task. So here we are using it only with a main task. Now we'll run this example and see what happens. So here we can see that our main task got executed and completed, but we can clearly see here that our two tasks, task one and task two, did not execute. The task one and task two are asynchronous functions, and they return the future. And futures do nothing unless you call them. So to execute this task, we have to poll them, and to poll them we have to add the await keyword here. So we'll add the await keyword here, and then again rerun this example. So here we can see that we got the task 2 completed and task 1 completed. So now we can see that, and we have two pause points here in our main task. The task 2 is our first pause point and task 1 is our second pause point. So main execution starts and it pauses here, and uh, till the task 2 completes and it returns the result, the execution is paused or blocked till this point. And once the result of this task 2 is available, then the execution is resumed. And then again at this task 1, the execution is paused. And once the result of this task 1 is available, the execution is resumed, and we get the our main task completed. So even though, so here we can see, even though the reading from the database requires less time, it got completed after the task 2, because the task 2 is called before the task 1. So this is not efficient. So to make it more efficient, we can use the join macro here. So join macro, it polls the async functions concurrently. So it allows multiple futures together and wait them to complete. And so basically uh, it polls the multiple futures simultaneously, and it returns the tuple of all the results once the complete. So we'll run this example again and let's see what happens. Okay, so here we can clearly see that the task 1 got completed first and then task 2, because the task 1 requires the less time and the task 2 requires more time. So the execution is handed over to task 1 first, and then once that the result of task 1 is completed, then the execution is handed over to task 2, and then the task 2 got completed. And after that, the main thread got completed once the result of this tuple is returned. So this way we can use the async function efficiently to make our program more efficient and performant. So here we used our block on executor and this join macro for the polling. But Rust, there is one library which is popular choice for working with async and await. So the Tokio library, it provides a runtime that can run a multiple asynchronous tasks concurrently and handle their scheduling and execution. So let's take take a look at the Tokio library. Now let's take a look at a Tokio library. One of the main feature of Tokio is its advanced scheduler, which provides efficient execution of multiple asynchronous tasks. It provides a runtime that can run multiple asynchronous tasks concurrently and can handle their scheduling and execution. Tokio also provides number of useful abstractions for working with a common I/O operation, and it provides number of other features such as tools for networking with asynchronous tasks, thread pool for running blocking tasks, a task scheduler and for scheduling a future work, synchronization primitives and channels. APIs for working with the common network protocols such as TCP and UDP, file system operations and process signal management, and timeout, sleeps interval, and high performance timer. Let's take a look at a simple example using Tokio library to understand more. So let's take a look at this example. It is a TCP server example taken from the Tokyo document. It's basically a TCP echo back server which returns data back to the client connector. So here we can see the TCP listener is bind to the local TCP port 7000. Then here we have an inside loop which runs continuously and accepts the new socket connections. Whenever a new client is connected, that connection is accepted and the socket is written. Now this return socket, whenever there is a new connection, a new thread is spawned using the Tokyo spawn, and this socket is passed to that thread. So inside that thread, there is again a continuous loop, and inside loop we have two asynchronous functions for reading and writing. So the first function is reading. Whenever there is some data available, that is read, and that bytes are passed to the write function, and then again those bytes or data is sent to the socket or the client connected. So basically this is the operation of this example, and whenever uh, there is a new connection, new thread is created using this Tokyo spawn. So there can be multiple client connected to this device and to this server, and each client will have its own thread created. Uh, so these methods in these loops are async functions. Uh, so these async functions return the future. Uh, the futures can be complete by other two ways, either polling them or calling await. The calling await works inside the async block or async function, but the top level um, functions, there has to be some code which will manually poll the futures. So for the top level future, we have executor, uh, which is provided by this macro. So at the compile time, this macro get expanded, and it generates a code which will act as an executor, and it which will manually poll the future and for until its completion. Now we'll run this code. So we have our TCP server running at 7000 port. Now we'll try to connect a TCP client. For that we are using this application. So here we can see we have already the new connection, and our client is connected. Now we'll try to send some data from the client, and our TCP server should send that data back to the client. So here we can see uh, that we are getting whatever we are sending to the server back. Similarly, we'll try to connect another client to our TCP server. So here we get a new connection and a new client connected. Again, we'll try to send some data. So here we can see whatever we are sending to the server, we are getting back. So here we have two threads running for each client connected. So likewise, we can use this framework to build a high performance network applications which can handle large amount of concurrent connections and perform multiple IO operations simultaneously. So the use of async await makes it easy to write a code that perform these operations in a way that is similar to the synchronous code without the complexity of explicit thread management. So in the next slide, we are going to see the practical use of this to build the web server using the Axum web framework. So here is our basic chat application using Axum web framework. We are using Tokio as a runtime here. So earlier we saw how we set up a TCP server, and whenever some TCP client gets connected to that TCP server and sends some data, so the same data is sent back to the client. But here in web server's case, whenever the valid HTTP request is received, so in response, some valid HTTP response is sent back. So to accept or to receive the valid HTTP request, we have to create some routes. So to define routes, we use this route method and passed two arguments to that route method. The first argument is nothing but a string which defines that route, and uh, the second argument is a corresponding handler function. So here we are creating two paths. Uh, this slash is called a root path. So whenever the HTTP client uh, connects to our web server, this root path is executed, and this handler function is the execution is handed over to this handler function, and in response to the HTTP request, the HTTP response is sent back, and in this case, the HTTP response is nothing but a index.html file. And another route is WebSocket. So this WebSocket handler is the corresponding handler function for that path. So this is used for the exchange of data between HTTP client and our web server. So after that, we have to set up a HTTP server. So to set up a HTTP server, we have to use this bind method and then call serve method on that. So it will create a continuous loop, and it will wait for the valid HTTP request on this defined paths. Let's run this example here. Now we have our chat application running on this 3000 port. We'll try to connect chat HTTP client. So here we can see we got as soon as we connect our HTTP client, we got this HTML response back. Uh, let's define this as a user one and then join chat. So in response to the join chat, we got this message back as a user one joined. Now we'll try to send some message here. So we send one message and it says user one hello, but there is there is no second client connected, there is nothing to receive that message. So we'll try to connect another HTTP client here. So we got the same HTML response back. So here we will define this as a user 2. So here now we can see the user 1 also got notified that user 2 has joined. Uh, so let's send same message again. So now we can see the user 2 got that message in back. Let's send back hello. So here we can see the user 2 send message, and user 1 also got that same message. So we can see here the data is being exchanged between this user 1 and user 2 with the help of this HTTP web server. So earlier we have seen that whenever some client gets connected to the server, the separate thread is spawned, and that sponsors that particular client till that client gets disconnected. So, but to exchange data between threads or across threads, there has to be some mechanism. So here we can see uh, this the axum library provides this state method to share some structure across these handler functions. So for each path, we have handler functions, and this whatever the structure passed to this which state is shared across this handler, and this handler function uses that structure to exchange data between different threads. So this abstract is nothing is it is a structure, and it has a here in this example here it has a user set which is a hash map, and this tx broadcast channel. So we can see the Tokyo the broadcast is from the Tokyo crate. So Tokyo provides some synchronization primitives or channels, and with the help of that, we can communicate across thread or exchange the data or share data between different threads. Okay, so this was just a overview which has given us a general understanding of the capabilities of async await, Tokyo, and Axum in Rust. It's clear that these libraries and frameworks offer significant power for building high performance network application. While this has been just a brief introduction, we will delve deeper into specific topics in future videos. Thank you for your attention, and we look forward to seeing you in the next video.